Hello, Godot makes use of resources a lot, which means it is very important to understand them. So within this in-depth resource tutorial, we will learn what resources are, when and why to use them, and after all that has been discussed, I will walk you through a step-by-step guide to using and creating custom resources here in Godot 4. There's a lot to cover today, so let's not waste any time. Please subscribe to help YouTube push this Godot tutorial to other aspiring game developers, and let's begin. Okay, so what are resources? Well, in simple terms, they are just files or data containers that store data which are accessible and editable through nodes. Why do I say through nodes? Well, because a resource can be created and saved, but it doesn't really exist or work until they have been attached to a parent node. And that's because they don't really do anything on their own except for store data that the parent node can reference. Now you may be asking yourself, that sounds kind of useless. Can't we just store data elsewhere instead of having to learn all about resources? Well, I actually stumbled across an amazing Reddit comment from Mantisa64 who stated, "Often the engineering value of something isn't what it does, but what it doesn't do. Resources do not exist in the node tree, do not have process callbacks, and are not copied by default when the scene or node that references them is duplicated. So if you make a node but don't use any of these features, then you should use a resource." But then branching from that, we can use resources to create very modular scripts, which are a tremendous boost to your workflow. But how can we really understand resources within Godot? Well, it is best explained if I first break it down into the two main types, pre-built and custom resources. Now keep in mind, all resources are the same, but pre-built resources are just custom resources that are automatically created by Godot. And then if we break it down even farther into real engine examples. For example, if I save this world scene and go look down in the file system, it says the world scene has been saved as a pack scene, which is a resource. Basically, this pack scene resource file will contain all the data it takes to construct a world scene. It just contains a lot of values, and the Node2D will take all those values and make something with it, which in this case is our scene. Another example would be when we have a tile map and we go and create a tile set resource. When we make changes to the tile set in the inspector, we are changing information stored within that tile set resource, like the tile texture, location, collision shape, and other properties of each tile. Then the tile map node uses the tile set resource to create the grid-based tile layout based on the data stored in that tile set resource. Now, that is an example of a pre-built resource where all the logic and variables have been set up by Godot themselves, but how can we create our own resource for our own needs? That is why in Godot we have the ability to create custom resources. The reason they are so special is because they allow you to manage game data and create reusable template sets of information, which will be a game changer to your workflow. My favorite explanation is that custom resources are like a blueprint to create one-time or reusable template scripts for structured data. Which then of course you can create an export var within any node script, drag and drop the resource and customize it differently within each node, then that script can pull custom data from that resource. Here's a simple example. Let's say you were to have a game with different weapons. If you were to create a weapon setting resource, you would be able to adjust the max distance, bullet spread, ammo counts, weapon type, and whatever else you need, all within that weapon setting resource, in turn keeping your weapon script much cleaner and having everything in one place. Along with the bonus of not having to create all those little variables for each new weapon or having a different script for each weapon type, since all the variable names pulled from the resource will be the same, but the values stored within them will all be different. That is just one of many examples, but now I want to walk you through step by step how to create and use custom resources in a tutorial style format. Okay, so firstly I want to walk you through all the basics with a simple walkthrough of like a calculator example, and then we'll move into creating an enemy based example together, which will be a lot more complex but should help you understand the power of resources much better. But for now, let's keep it simple. Let's learn the basics because they're so vital to be able to understand how resources actually function within Godot. So to get started, we have a completely empty scene. There is absolutely nothing here but a parent node 2D, which is just a node 2D that I renamed. And as you can see, we have a resources folder, a scenes folder, and a scripts folder, but there is absolutely nothing within them except for this parent node 2D scene, right? So what do we want to do? How are we going to want to be able to go about this so we can understand what a resource is and how to use it? Well, firstly, we need to actually learn to create a resource, right? Because right now we don't have any resource in our game. We can't do anything except, let me show you one thing. If we come up here to the right under the inspector, this little page with the plus, if we click this, this is creating a new resource. So these are all resources here, but these are all pre-built resources that Godot has created for us. How do we create our own custom resource, right? Because that's what we want to know. So to do that, we can come up here to the scripts tab, file, and just create a brand new script. And instead of inheriting a node, we want this resource, or we want this script to inherit a resource, right? So if we do that, and then we can rename it to whatever we want. For example, in this example, this is going to be our calculator resource. This is how we're going to create a little calculator in our game. So we can call this the calculator resource, and then we can click create. Now we're going to have a new script, which up here at the top, you can see it extends a resource. Okay, so that's all good and everything, but what can we actually do with this script? Well, like I mentioned earlier, the resource is like a data container. This really won't do anything except store data, and we can also end up adding functions within it as well, but we'll go over that in just a minute. So first of all, since this is a resource, let's just store some data. Let's store two numbers, right? So because it's a calculator, we're going to end up needing two numbers. So we can say, okay, number 1, which is going to be an int, and then we can also say export var number 2, which is going to be an integer as well. Now that's good, but how do we add this resource into our game? How do we create this resource? Because right now we have the resource script, but we don't actually have a resource. So like I mentioned earlier, up here, if we click on this plus button, we can end up adding in a resource. So if we do that, you're going to see that we have all these resources. These are all pre-built, but how do we actually find our own resource? Well, we have to give our resource a name. And to do that, we can just create a class name up here at the top and name it whatever we want. So for example, calc resource, right? We'll just call this our calc resource. Then if we come up here and we add in a resource, you're going to see that if we type in calc resource is going to come up. If we click on this and click create, you're going to see that over here in the inspector, we create a brand new resource with number 1 and number 2, which are the two variables that we want to store. So let's maybe set these numbers. Let's set the first number to number 4, and let's set number 2 to be number 7, right? And then if we click on save and save this resource into our resources folder here, we can name this our calc set 1, right? This will be our first calculator set because we're going to have multiple of them, so we can interchange it within a calculator and see how it functions. But if we do that, we can store this data, and then if we come over here to the resources, you're going to see that data is going to be stored within this calculator set. If we come up here and we create a new resource, calculator resource, right? And we change up the numbers, maybe to 9 and 3, right? And then we save this as the calc set 2, you're going to see that we're going to have two different calculator sets. If we go to calculator set 1, we have 4 and 7. Calculator set 2 is going to be 9 and 3. We have two different files and they store different values, right? So these are basically our two different data containers. But how do we use this within other nodes? So up here at our parent node, let's go up here and add in a new node. This node 2D is going to be called just calc1, right? It's going to be our very first calculator. And we can create a script on this, which is just going to be extends the node 2D. It's just going to be a normal script, right? Save that into the right folder down here in the file system just to keep everything organized, just like that. But in this script, what do we want to do? Well, if we come up here to the top and we create an export variable, and this variable can be the resource, right? And then this can store a resource. We can come up here to our calculator, go to the inspector, you're going to see this resource variable. If we grab one of these resources and we drag and drop it within the resource folder, now we can access that resource within our script. So, for example, in the ready function, we can say, okay, well, let's get our resource. Let's print something. We can print our resource dot number 1, right? Number 1, I believe we called it, right? So resource dot number 1, we can print that. If we click play with F6, you're going to see that in the output, we're going to print number 4. If we switch that resource file without switching anything within the script, and we switch it to be calc set number 2, you're going to see number 1 is now equal to 9. If we click play, you're going to see that we're going to end up printing off number 9. If we switch it back to calc set 1, we're going to have number 4 and 7 there, and you can kind of see how those values are stored, right? So moving from this, that's kind of how you can access the information, but there's more to know about resource. So if we go back to this folder, or back to our resource script, we have just two variables, number 1 and number 2. But what else is important when you're using a calculator? Like if we think about it, what else is important? Well, the symbol is important. The add, the subtract, the divide, that symbol is very, very important. And we only have 4 symbols. We don't want to have to input like a plus sign, right? We want to be able to input or have like a drop down and pick the symbol that we want or the action that we want to happen, right? So to do that, we can create a enum. So we can say export var the symbol, which is going to be part of whatever enum we create. So if we create an enum and we name this these symbol types, right? And then we can create all of our different symbol types. So what example, we have add, we have subtract, right? And then we're going to have divide, and then we're also going to have multiply, right? And then we can save that, and then up here at the export variable, we can import that enum as the symbol types, enum, And this variable, if we come over here, you're going to see that if we have a drop down now and we have different options. So that's kind of how you create an options variable with these these four different options we have. We only want symbol to be equal to one of these options. So we can come over here and then now we can pick, okay, well, let's 4 subtract 7, right? Or 4 divide by 7, right? Now we can decide what action we actually want to do. So that works there. But what else we can do in resources is create functions. So let's maybe create a function to find the number that we're looking for, right? So for example, find number, we are going to take number 1, number 2, and then we're going to take the symbol type and we're going to create the number of our calculation, and then we can send that number to our parent node. But we can change the numbers here based on whatever node they're on, if that makes sense. It's going to make more sense in just a minute. So let's set this up. So let's say, okay, var number, when we find our number, we want the number to be equal to an integer. We can use the match function here in Godot to match our symbol up here with 0, right? 0, 1, 2, or 3, because this add is equal to 0, subtract is equal to 1, divide is equal, right? Basically, that's kind of how that right there functions. But we can say, okay, number is going to equal an integer of number 1 plus number 2, right? But if the enum, or if the symbol variable is equal to 1, that means we're going to want to subtract. So then we can subtract these two numbers. If it is equal to 2, that means we're going to want to divide. So then we can divide these two numbers. And then if it is equal to number 3 here, then we can multiply these two numbers. And then we can just return number, since we are going to be calling this from a different script. So return the number, right? So that works. Now, this is where resources get fun. If we come up here to the calculator, right, we can say, okay, let's create a script just so we can print off our number. So we can print that function. So we can say, okay, well, resource dot find number. Is that what we called it? I think that's what we called it, right? Okay, we called it find number. So we can say, okay, print resource dot find number. So we're going to take the resource that we have and then we're going to find the number based off the values within the resource without having to set anything up, right? So for example, we have calc set number 1 attached to this calculator. If we say maybe 5 times 10, right? And then we can say multiply. So 5 times 10 should equal 50. If we click play, you're going to see it's going to run that calculation and it's going to put 50. If we do subtract, it's going to be -5. You're going to see we're going to get -5. If we add, it should be 15. And you're going to see that that works, and we can do this with whatever number we want, right? Just like that, 105 or 1005. And then let's say that we have different set resources. So let's go to calc set 2, right? And then we can drag in calc set 2, and you're going to see those values are going to be stored from earlier. And then if we drag in calc set 1 again, you're going to see that those values are what we just had. So calc set 2, we can set maybe calc set 2 to multiply. Maybe you have a function and you have 10 and 3, right? And you have 10 and 3 for both of these values. Maybe it's to find the health, but it depends. Sometimes you want to divide it, and then sometimes you want to multiply it. You can have two different resources. You can go, okay, well, in our calc, let's go to resource 1, which is going to be the divide resource, right? And then you're going to see we're going to get 3. If we switch that resource right now to resource 2, you're going to see that we're going to get 30. Maybe you want another one for subtracting. You can go up here, create a new calculator resource, and within this resource, we can say, okay, well, 10 and 3, and then maybe this time we want to be able to subtract it. We can save this resource, save it as the calc set 3, right, resource. And then, boom, just like that, we can come over here to our calculator and we can drag and drop this resource, and you're going to see that those values are going to already be set, right? But it's also important to know that we can have names for these different nodes, right? So another, for example, variable that we can have on our resource is a string. So we can say, okay, we'll export var, right? Export var name, and that can be equal to a string. So now we can name each node, or each node will now have a name. So for example, if we go to calc 2 and we give this a name, calc 2, right? And then we go to calc 1, and then we give this a name of calc 1, right? Then we can say, okay, well, let's go into our calculator 1 script, which is the script that's shared between both of our different calculators here. We can say, okay, well, for the number, let's put it into a variable. We can say, okay, boom. Then we can say resource dot find number, right? So then we can call that function. We can find the number here in this resource, which looks good. And then down here, instead, we can print that name. So we can print that variable. Instead of calling a function, we can just straight up print a variable here. So we'll print name, and then we can print something like this, just so we can print off that number as well. And then you're going to see what happens there is we need to make this all into a string real quick, since we have an integer and a string. And then if we click play, you're going to see that both of those are going to print off their name, and then they're going to print off the value that is within the resource. If we go to calc 1, we change up the numbers a little bit. That's 100 minus 3. Click play. You're going to see that everything is going to come together, and everything is going to work exactly like it should. So that is the little calculator example. That's kind of the basics of the resources. But now let's move into the enemy example, which is going to be a lot more I don't want to say complex, because it's really not complex, but you're going to be able to understand how they work and why you actually use a resource. Because right here it's kind of like, well, what's the point of even using that? But I just wanted to cover the basics, right? So let's create a simple example together. We have a few enemies which are all the exact same scene. We want them to function similar, but we don't want them to all be the exact same. For example, we want different speed, different damage, different health, different appearance. But instead of creating many different scenes for this, we can use that one enemy base scene and then create resources which are going to set the enemy's differences, right? And so it's going to end up coming out to look something like what you see on screen now. Okay, so here we are. This is the project that we currently have. We have a world, we have a static body, which is just basically creating this little world with a collision shape. And then we have the enemy base scene, which is just a sprite and a collision shape. And if you want to copy that script down, you can see it's very, very basic script. We have a start position, a moving right, so we can kind of see which way we're moving. We have a speed, a movement range, and then we kind of basically randomize the start direction there. And then this is basically the movement script for our enemy, so it just moves back and forth, and whenever it hits its movement range number, then it's going to go in the opposite direction, if that makes sense. So if you want to copy this down, you can, but there is also going to be a link for this on my HIO page. You can download it for completely free, link in the description, so you can follow along with this tutorial, right? But if we go to the world and we click play, you're going to see that these enemies are all the exact same. Now they go in different directions because it's randomly generated, but they have the same speed and they do the exact same movement, right? And they look the same as well. So how do we change this? Well, we're going to create an enemy resource script, which is going to set the differences that we want for these enemies. So remember, how do we create a resource? Well, we can come up here to the scripts tab and we can go file, new script, and we can call this here a resource, right? We want it to inherit a resource. Now, what do we want to name this? Well, we can just name it our enemy resource, right? Because that's what it is, our enemy resource.gd, and we can create that just like that. Now, it's going to extend resource. Remember, we can give our resource a name. So we can say, okay, well, class name is going to be the enemy resource. Our enemy, I guess, type, enemy type. We'll just call it the enemy type. And we're going to have some different variables. What data do we want to store within this resource for our enemies? Well, let's think about it. So maybe we're going to want a name, right? So we need a name for our different enemies, of course, right? So we can use string for the name. What else are we going to need? We're going to need the type of enemy, right? Is it going to be the red enemy? Is it going to be the blue enemy? Or is it going to be the green enemy, right? So we'll say, okay, that we're going to end up using an enum like we used earlier in the basics section. But we'll say var type, which is going to be equal to types, which is going to be our enum, right? So this will be equal to types. And then we can come down here, we can create the enum, and then types, which is going to be equal to red, blue, and green, which is basically really just going to set the appearance for the two different things, because red, blue, and green are going to be set in a resource, and they're going to be a set in stone resource that we don't change throughout the game, but it's just a set resource, if that makes sense. But we'll get to that. So these are going to be our types, right? What else do we need to store within our enemy resource to make it different? Well, we're going to have an export var. We're going to set the speed, right? We're going to maybe set the movement range within this resource here, which is going to be a float as well. And then, for example, you can also store other things like the damage, right? The damage that this enemy does. You can also store the health that this enemy has, right? Because for the most part, you're going to want the enemies to do different damage and have different health based on their type, right? So we can do that. But for example, in this example, we're not really going to be using these, but we are going to have them set, and they are going to be stored within our enemy because that is pretty important. And then we're going to want to change the appearance. So to make that the easiest in this situation, we can end up doing that with a function down here, which is going to be a function to find the appearance, right? But we'll do that in just a bit because it's not too important yet. It's not too important right now, as in getting everything set up, right? So to create the new resources, we can come up here to the, remember, inspector, click on this little plus button. We're going to pop up this window, and then we can type in our new resource, which is going to be our enemy type resource. Create this resource, and you're going to see over here, we're going to have the enemy type. So we can set this up. So for the first one, we'll do the red type. We want this to be called hot square, right? So hot square will be the name. Maybe the speed for hot square is going to be very, very quick. So it will be our fastest one. The movement range can be set to like 300, so it can move pretty far because it is, again, the quickest one. The damage 75, and then we can just set its health to 100, right? And then with that set, we can come up here, save this resource into our resources folder, and we can just name this as the red enemy, right? So the red enemy resource, just like that. Now we can come up here, we can create a new resource, a new enemy resource. We can call this one the cool square. This will be the blue one, right? So we can say this will be the blue type of enemy. The speed maybe is basically half of blue or half of red, because it's like, I guess, a cool square. It's more nonchalant about things. We can say its movement range is 200, maybe a little less. Its damage, it doesn't do too much damage, and it also doesn't have too much health, right? And then we can come up here, save this into our resource folder as our blue enemy. And then we can come up here, create one more, because we want one more type of enemy, which is going to be our weak green, right? So we'll just call it weak green square, which sounds like a fun name. It will be type green, and the speed that green is going to have is 30. It's going to be the slowest of them all. It's not going to move much distance. It's not going to do really any damage at all. We'll say it will do 1 damage, and then its health can be set to 1,000, right? So it's going to have so much health, but it's going to have no damage, right? So now basically our blue, or let's save this first as our green enemy. So we have the blue enemy now, and you can see the stats for the blue enemy. We have the green enemy, you can see the stats for the green enemy, and then we have the red enemy, and you can see the stats for the red enemy. Now those are all set in stone. We're not going to change them throughout the game because that's what we want that specific enemy to have. So within our enemy base scene, how can we set these differences? Well, we can go into our enemy base script, and we can create a variable for that resource. So maybe we can say, okay, var enemy type, right? Our enemy stats, I guess. Enemy stats, and that can be equal to a resource, right? Just like that. Then we can come out here to our 2D scene. Let's create one of each. So for example, the enemy base blank, or the enemy base 1 is going to be our red enemy, right? So we can drag and drop that. Enemy base 2 we want to be our blue enemy, and then enemy base 3 we can make our green enemy. So now if we drop these down, you're going to see that enemy base 3, these are the enemy base 3 stats. Enemy base 2, these are the enemy base 2 stats, and then enemy base 1, these are the enemy base 1 stats. And you can kind of see the difference between those when we cycle through them, right? But how do we access this information within the script? Well, we already did actually go over that, but we're going to end up coming down here and, for example, removing speed and movement, because we're not going to need that anymore since we have that stored within enemy stats. But we're going to have to come down here to this and say enemy dot stats, right? Our enemy stats dot speed, right? So we can access the speed within the enemy stats resource. Enemy stats dot movement range, and then again enemy stats dot movement range. So we can access all that information through our enemy stats resource. But again, this enemy base.gd is the exact same script for all of these. So they all use the exact same script, but the only thing different is the resource, and you're going to see how big of a difference that makes within our world. So if we click play, you're going to see that this one's going to be faster. That's the red enemy. You're going to see the blue one's going to be a little bit faster, and then the green one, of course, is going to be the slowest, but they don't have color. So how would we assign color to them, or just assign a different texture, right? Well, that's what our find appearance is going to be for over here. And to set the appearance that we want, we're going to end up using a match function like we used earlier in the other example, right? Because we're going to want to match the type within the resource. So for example, if we look at this blue resource here, you're going to see the type is equal to blue. If the type is equal to red, then we want it to equal red. If it's equal to green, then we want it to equal to green, right? That's what we want the appearance to be equal to. So if we call the function find appearance, what do we want to do? Well, what are we looking for, right? We're looking for the color that we want it to be set to. So we can create a variable. We can set this to equal to a color. How do we know what color we want the appearance to be equal to, right? We're going to use that match function. We're going to match the type variable, and we're going to match it with the different things. So if we have type red, which is 0, then the color is going to be equal to a color. Now, this color needs to be equal to red. So I actually did this over earlier just so we don't have to go through and find the colors together, because that would be actually a little time consuming. So these numbers right here equal to red. So this is the R color, the B color, the G color, and then the A color, which is the transparency, right? So if it's 1, then it's fully visible. If it's 0, then it's completely transparent. But if you want to find these values by yourself, you can come over here to the sprite 2D and modulate, and then you can come over here. You can pick out whatever color you think fits best. So maybe you want this color, then you can go to raw and you can take these numbers, right? You want to make sure that you take the raw number, because if not, then it's going to come out really weird and you're going to end up putting big numbers into a value spot that should have small numbers, if that makes sense. So the color will come out really funky if you don't put numbers that are under 1. So just make sure whenever you import your number over here onto your resource that it is under 1, because 1 is the max value and then 0 is the minimum value. So that's why all these numbers are going to be decimal numbers. But if we are equal to, for example, blue, then we want the color to be equal to this color here, which is 0, 0.53, 0.95, and then 1, right? But then again, for the most part, in a real game, you aren't going to be doing what we're doing here, because we're just changing the modulate, and for the most part, that's not going to be how you're going to differentiate the enemies, right? You're probably going to differentiate them by having completely different textures, and you can just do that by having a texture 2D, right? So for example, let's say you did want to do it by having a completely different texture. You would have export var texture, right? So it would be the enemy texture, and the texture would be equal to, for example, a texture 2D, right? And that's capital T, I think we need there. So a texture 2D, just like that. So then over here on, for example, the resource, if we come over here and we open up the blue resource, you're going to see the texture, and then you can end up dragging in your own texture there. And then you can set the enemy based on that texture. So then instead of like doing what we're doing here and finding a color, you would end up just saying, okay, equals texture. And I'll show you how we do that. But down here, once we find the color that we need to make sure that we return the color, right? But for example, if we wanted the texture, how would we set the texture? Well, we would come over here to the enemy base script, and then in the ready function, we can say something along the lines of setting the texture. So you would say like texture self.texture equals to whatever the texture is that you have, right? And then you would basically call that line. For this function here, or for this example here, we're going to end up just changing the self modulate. We're going to change the modulate of the entire enemy, right? So to do that, we can just say, okay, set modulate, and we want the modulate to be set to the enemy stats dot find appearance, right, function. So basically we'll just get enemy stats, and we'll call that function, and then that function is going to return the color based on the type that the resource is set to. So for example, if it's set to blue, then it's going to return this color here. If it's set to green, then it's going to return this color, right? And it's going to return the color based off the type of enemy, and then it will just set that appearance. So you can see that the script is still the exact same for every single enemy, but if we go over here to the world and we click play, you're going to see that we're going to have a much different outcome for the enemies, right? And so I guess we didn't spell that appearance right over here. Must have misspelt that, but we can fix that up real quickly, and then come click play. And you're going to see what happens is we're going to have that blue enemy, we're going to have that green enemy, and then we're going to have that red enemy. You can see the green one is the slow one, blue one is the medium speed, and the red one is the fast one. But if we come over here to our 2D scene and we say, okay, well, let's set the self modulate back to default, right? Because it wasn't set to default. But if we come over here to the enemy base scene, let's say this is our red enemy. Maybe what if we wanted 3 red enemies, right? Well, we can come over here to our resources down here in the file system. We can drag in a red enemy on each enemy base, right? So now all 3 enemies are going to be red because that's the resource that they carry. If we click play, you're going to see that every resource or every enemy is going to be red. Maybe we want one of them to be green. So we want 2 red and then a green. We can change this one to equal to green. You're going to see that enemy 1 is going to be equal to green. The other 2 are going to be equal to red. Maybe we want this one to be equal to blue. So we want 2 red and a blue, right? And you're going to see how that works. And then we can just have so many different enemy types based on just dragging and dropping. Maybe we want them to all be slow little green ones, right? We can change the resource here within all of them to equal to green, and you're going to see that the outcome there is going to be all green enemies. So basically we can completely customize our enemies now based on just dragging and dropping in a resource file within them here in the enemy base.gd. Now I hope that that example there was able to kind of help demonstrate how resources can be used and how to use them and things that you can do with resources here in Godot and kind of the beauty of them. But I do want to tell you some things that you should keep in mind that I want to mention about resources that I think are so important for you moving forward. Because again, this video here was more about the basics and it was simpler. But now speaking about your own projects, if there's something in your own project that you think you may need to reuse or simply just share across different scenes and nodes, then a resource may be the way to go. Because again, resources help to share data between nodes and scripts while keeping all the data organized and separate between those different individual nodes is loaded within. But overall, resources are really going to help you keep the project simpler and more organized, along with allowing you to create reusable data containers which can be used all throughout the project, which of course is going to help boost your workflow so much. Now again, I know this video was more on the simpler side and it was more over just the basics, but the basics are so important because if you understand how and why the resources are functioning the way that they are, then you can go and do some amazing things with them in the future. But as you learn about resources, if you ever have any questions about resources or you're having any trouble deciding whether you should be using a resource for a particular situation, then feel free to ask in the comments below and I'll be sure to get back to you. Again, thank you so much for watching. It really does mean the world to me and I hope this tutorial was able to provide you a bit of value. Again, thank you so much. Stay safe and have a wonderful rest of your day. God bless and bye-bye.